Valence electrons.
We're going to talk about valence electrons. So down at the bottom it says number of valence electrons for each column or group. So up and down are columns known as groups. You want to pay attention to how many are in the last shell that's holding electrons. So hydrogen has 1, lithium has 1, sodium has 1. So what do they have in common? They all have 1 electron in their outer shell. So 1 valence electron for all of these. Here, beryllium has 2, magnesium has 2. So all of them in the second column will have 2. 2 electrons in their outer shells. These are known as valence electrons. Taking carbon off of the periodic table, looking in the box, it's in period 2, so that's the row side to side. That tells you the number of energy levels that carbon is going to hold electrons in. So it's going to have 2 shells with electrons on them. It's in group 14. Groups are up and down, they're columns. That's what tells you the number of valence electrons the atom has. Valence electrons are the electrons located in the outermost energy level of an atom. So it's the outer shell. Each group is going to have a certain amount of valence electrons for all of the elements in that group. That's up and down, columns. Example, group 1 has 1, 2 has 2, we skip the middle, 13 has 3, 14 has 4, and so forth. We skip the middle because transition metals are the exception to the rule. Groups, they're columns that go up and down. Each one has a specific number of valence electrons. Group 1 is 1, 2 has 2, we skip the middle, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, 18 has 8, except for helium because it only has 2 electrons total, so it's going to have 2 valence electrons. On this page, we're going to use our knowledge of valence electrons and what they are to fill it out. We're not going to do this, so don't worry about this. We're just going to put how many they have. So if you use the periodic table, the first one is fluorine, okay? It is in 17, so it has 7 valence electrons. So I just want you to write a 7. Then phosphorus is in group 15. It's going to have 5 valence electrons. Okay, that's all you have to do. Valence electrons are important to consider when it comes to chemical bonds and chemical reactions. These electrons can be represented in a diagram called an electron dot diagram. The outermost electrons are drawn as dots around the chemical symbol. For most of the elements, a complete and stable energy level is going to have 8 electrons. So the electron dot diagram has up to 8 places to be able to draw the electrons. Hydrogen and helium are exceptions because the first energy level is stable with 2 electrons. So looking at the diagram, you can see you can only have 2, up to 2, on each side of the symbol.
Steps for drawing electron dot diagrams.
First step is to write the symbol. So here's an example for chlorine. Then you use the periodic table to determine how many valence electrons the element has. Look at which group it's in. Chlorine is in group 17, so it will have 7. Step 3 is to draw a dot to represent each electron in the outer level or shell of the element. 2 electrons can be placed on each side of the symbol. The first 2 should be placed on the right side, and the remaining ones will be drawn one at a time, moving clockwise. Basically, just don't have more than 2 on each side. As you can see, the final answer for chlorine has 2 dots on the sides and the bottom, 1 on the top, making 7. On this page, we're going to use our knowledge of valence electrons to make electron dot diagrams. All right, the steps are here, but I'm just going to go over them with you. So the first thing you do is you write the symbol, hydrogen. And then you look and see which group it's in. It's in group 1, and all of these have 1 valence electron. Okay. So we're going to put 1 dot. It's that easy. Now, you can only have up to 8, and it has to have 2 on each side, max. So neon, if we look at our table, it's in group 18. It's going to have 8. So all of the spaces are going to be full. First, you write the symbol in E, and then you put the amount of valence electrons, and it has 8. So 1, 2, 3, 4, and we go in a clockwise manner. 5, 6, 7, 8. And that's all.